So for this learning intention, I feel like it would be a lot of revision over what you've learnt over the last few years at school. So this is I can use measures of centre and spread to describe discrete and continuous data. So our measures of centre are, of course, our statistical averages, and you would have heard in the past about our mean, as well as the median, and finally the mode. So this should be some really quick reading for you to do to just revise yourself with how we find them and if there are any particular formulas if that we need to use to find any of these. The main thing we would like you to really look at though is some of the advantages and disadvantages of using some of the different types of measures of centre, as well as later on when we talk about the measures of spread as well. So of course, the advantages of our mean being that it can include all data values, and so that therefore it considers all of the information in our data. Whereas the disadvantage of it being is that it can be easily influenced by outliers. Our advantages of the median is that, well, it's not really affected by our extreme data values or our outliers, but the disadvantage means that it then therefore does not consider the value of data values, only the position of where they are actually in. So just a few key things to be thinking about. The other thing, of course, is our measures of spread. So this gives us a measure of the variation in our data. So the lows and the highs, the maxes and the minimums. So of course, our range is the difference between our highest value and our lowest value. We've got our interquartile range that is found by doing the median, which is our Q2. Then we want the median of the lower half, which gives me my quartile 1, and then the median of our upper half gives us our quartile 3, and then the minimum and the maximum, which is just kind of our range, really. And just keeping an eye on what these different quartiles kind of represent in terms of our data and the percentages there. The really big one, or I guess one of the main ones that we want to be thinking about is our standard deviation. You're definitely going to need this for when we start looking at and learning about our normal distribution curves. So this is quite an important one to know. So if you did 10A last year, you would have heard about standard deviation, how to calculate this, and essentially this just kind of tells us how spread out our data is about the mean. So really a low standard deviation means that all of our data is close to the mean, whereas a larger standard deviation means that they are more spread out from our mean. And it is calculated using this really fun formula, though of course you'll be able to use your calculator for this. In the examples, I will show you how you can be able to calculate this using a table, just to make this calculation or formula look a little bit less scary. So essentially, our standard deviation is equal to the square root of the sum of our x take mean squared values over n, so the number of data values that are there. So this will make a bit more sense when I go through the example down below. And then again, there is a table down here that talks about all of those advantages and disadvantages of the different measures of spread. So I do encourage you to read this because it is good to practice being able to write and articulate and really kind of go a bit deeper into some explanations when the questions ask you to do so as to why or the differences between different sets of data values. And then, of course, down below here, we've got your calculator instructions. Again, I'm not going to go through this. You should be able to read these instructions here on how to find the mean, mode, median, range, and interquartile range, as well as the standard deviation, using all of these calculator instructions here. In this question, we have a greengrocer who purchases oranges from two different wholesalers. So this is Sunblest and Valencia Star. He takes 5 random crates from each wholesaler and counts the number of blemished oranges in each. So we can see here in Sunblest, from their first crate, there was 4 oranges with blemishes, 16, 14, 8, and 8. And then for Valencia Star, the number of blemished oranges was 9, 12, 11, 10, and 13. So the question is asking us to find the mean and the standard deviation of each set. Now, the easiest way to do this is to, of course, look at them separately. So for Sunblessed, we are going to calculate their mean first. So, of course, that's represented by my x bar here. And obviously, it's the sum of all of these divided by how many there are. So I'm going to have 4 plus 16 plus 14 plus 8 plus 8. And that's going to be all over 5. And this gives us a nice number of 10. Now we're going to find the standard deviation. So we know that we've been given this formula for standard deviation that is equal to the square root of the sum of my x take x bar squared all on the top of n. So it looks like this. Now, of course, we can solve this by using our graphics calculator, and the instructions are in the notes. The other thing we can do, however, is to actually create a table to better actually understand what it is this formula is calculating. So if I create a bit of a table, it's not going to look the best, of course. Coming along like so. And I'm going to call this my x. And I'm going to create just a few down here. Alright, so I'm going to have this be my x take away x bar. And here I'm going to have my x take away x bar squared. And underneath, I'm also going to get a total as well for this final bit. So we know that my different x values for Sunblessed is 4, 16, 14, 8, and 8. Now my x take x bar, well, you can see here we've got our mean, and that is in fact 10. So for this first one, I'm going to have 4 take away 10, which gives me minus 6. 16 take 10 gives me 6. 14 take away 10 gives me 4. 18 take 10 gives me minus 2. And then, of course, a further 8 take away 10 is also minus 2. Now, the reason why that we have to square this x take x bar is because of my square root here. We know that a negative square root does not exist. So we need to square these numbers to get rid of any negative numbers that could potentially cause this whole thing under the square root to not exist. So minus 6 squared is 36, and of course just 6 squared is 36. This will come to 16, 4, and 4. And we can see that it is the sum of my x take x bar squared. So it's the sum of all of these added together. So if I added all of these together, this would give me 96. So to write this a bit more simply, this would become the square root of 96 over 5, because there's still 5 of them in total, which in your calculator would approximately give you 4.38. So this is my standard deviation. This is how much my different variables are deviating from the mean here. So at approximately 4.38. So this was just for Sunblessed. The same can also be completed for my Valencia star. And this is going to be, whoops, let me change that to a bit closer and change it into a colon. So Valencia star, I've got my mean again, which is 9 plus 12 plus 11 plus 10 plus 13, all over 5. And this is equal to 11. So I encourage you to do this table again yourself with Valencia star and see if you get the same answer as what I do. So I'm going to skip this table and I'm just going to go straight to writing out my standard deviation. So the sum of x take x bar squared over n, and this is going to be equal to root 10 over 5, which is approximately 1.41. So this is my standard deviation for Valencia star. Now, the other thing, or the other part of this question that it asks, is for us to compare our wholesalers here. So, the main things we're looking at comparing is, of course, our two means here, as well as our standard deviation. So, we can say that the sun-blessed oranges generally have less blemishes, and we can see that from the mean of both of them. I mean, very slightly, but, on average or in general, the sun-blessed oranges do have less blemishes. However, the Valencia star have oranges that have less variability in the blemishes, right? So oranges have less variability. So you could pick up a crate of sun-blessed oranges that, could deviate quite far from the average of 10. Or we could get the Valencia stars knowing that, on average it might have a few more blemishes. However, it is to be a lot closer to the number of 11 rather than, looking at near 14. Maybe we're looking at more so around the 10 or 12 mark compared to anywhere between something like less than 10 would get me 6, or 4 more than 10 would give me 14.